Hi, my name is Kyle Lyon. I'm a systems architect here at Solutions PT, which is the AVEVA Select UK and Ireland distributor. And in today's episode of Tech Bytes, we're going to be doing a deep dive into how to set up the Insight Performance module. So this is a two-part Tech Byte. So if you're watching this on our website, look out for part 2 releasing very shortly. It will be in the list that you can see. And if you're watching this on YouTube, then you should see part 2 in the up next section on the right-hand side, and it'll also be linked in the description below when it's released. Part 1 will cover setting up the equipment, equipment states, OEE targets, and good and bad production metrics. While Part 2 will cover additional properties relating to a production run, an overview of connecting to tags from our automation data sources, and finally mapping our equipment into production lines. So to start with, what is the Insight Performance module? This module provides some MES functionality within the Insight platform, helping you to understand and track things like asset utilization across a site or multiple sites by providing tools for tracking the availability of assets, the performance of those assets, how much are we producing versus how much they should be able to produce in theory, and the quality of the goods that we are producing. Are we meeting acceptable quality guidelines, or are we having a lot of scraps or reworks? And we can track things like the reasons for those to help make some better use of our engineering time. So these three metrics are the availability, performance, and quality come together to define our overall equipment effectiveness, or OEE metric. These metrics are then made available in these ready-made dashboards that you can see on the screen here. This example here is in the publicly available Insight demo. So if you go to online.wonderware.eu, you hit the big blue Try Demo Now button, you can navigate directly to here. You can have a look at what I'm seeing here, but we are effectively going to be building this system within our own Insight solution as part of this video. The idea being that once we've got these metrics available, we can then loop them in with the larger functionality of AVEVA Insight. So we can bring them into other charts with non-OEE based data. And we can also set up condition-based alerts so that, for example, if our performance drops below a certain level, a shift supervisor is alerted, or we can generate reports and things like that. Okay, so we're in our own solution here. So like I say, you could follow along with this video if you want, if you have a 45-day free trial that you're using, or you have your own solution that you haven't quite set up the performance feature in, you can feel free to follow along with this process. We're going to be using the built-in sample CSVs within Insight for this. So these files will be available to you from within Insight itself. For the sake of speed, I've just downloaded them myself to a folder so I can just drag and drop to speed up the video. And the process to import or to grab those CSVs and then import them will be the same each time. So what you do is you go to the efficiency tab in the administration in Insight. You pick the particular part of the model that you want to configure. You come up here and click the import button, and you can see download sample file. That will give you the CSVs that I'll be using. So first up, we need to create our equipment. Naturally, to track efficiency for our fleet of assets, we need to define each piece of equipment that we are interested in. For this demo, we're going to be modeling a bottling process for two separate sites. Each site has a line, and each line is comprised of a filler, a capper, a case packer, and a palletizer. So in this particular section here, we're providing the namespace and the name of our equipment. So I come to import and I drop in our first CSV file. See that that's uploaded successfully. And now when we refresh, we can see that those have been added. So here we're providing the namespace that these particular assets are related to and the name of the equipment. We're also providing a description for that particular asset and its location in our asset hierarchy. If you're not familiar with the Insight asset hierarchy, we do have some other videos on the channel and available on our website where we talk about that in more detail. If the hierarchy doesn't exist already when the CSV is uploaded, Insight will create it for us. So you should have a populated list like this, like I say, 2 sites, one in Austin and one in Houston, and each one being one of those lines that we mentioned. Next up, we have the equipment states. So an equipment's efficiency is tracked as we enter utilization events and apply a utilization reason for each event. So, for example, that would be, if an asset is running, is it running at full speed? Is it running at diminished rate? Things like that. So the reason indicates why that equipment state has changed. So it's important to track, are we in instances of planned downtime versus unplanned downtime so we can calculate our OEE properly. At all times, a piece of equipment will have an equipment state assigned to it. So for example, that could be running, idle, planned downtime, or unplanned downtime. We'll be setting up the specific reasons next, which will give us some more detail on what exactly has happened. But here we're just setting up the broad categories. So if I drop in our second CSV file, we can see that we now have not occupied, planned downtime, running, and unplanned downtime. You'll also see that we're assigning colors to these states. These will influence the colors that we'll see on our OEE Gantt charts that I showed at the beginning there. While we can't change the colors associated with runtime, idle, and downtime, they follow the standard traffic-like system, we can add our own new states if we want as well, with their own colors. There's a full list of supported equipment state colors in the help files under the heading equipment state column, so you can see the list of colors that we have available. You can have multiple equipment states associated with running, unplanned downtime, etc. But so long as they belong to the broad state of either in runtime, downtime, or idle. So before we can set up our OEE calculation definitions, we need to define some utilization reasons. Like I said, the equipment states are the state that a piece of equipment is in, and our reasons are the reasons why they are in that state. It's critical for understanding the difference between things like planned downtime and unplanned downtime. So in the optional section, select your utilization reasons, and you'll see here we've got 4 subgroups. The first, which is utilization reason groups, allow us to organize these reasons into groups and subgroups to make them easier for you to manage and for users, usually operators, to find when assigning them to events. So some examples of utilization reason groups might be planned stoppages, unplanned stoppages, electrical faults, and mechanical faults. If we set up these reason groups, it makes it much easier for a user to pick from what could potentially be quite a large list of reasons. The group hierarchy here can be up to 5 levels, so we can go 5 trees down into subgroups. If a reason group contains no individual reasons or no subgroups, it won't be shown to users when they're selecting a reason for an event, that being because obviously it's a group with no members. And an individual reason can be a member of more than one reason group. So if I pop in my CSV here, we can see that that's made a hierarchy for us. So we've got not occupied, planned stoppages, unplanned stoppages, and running. If we expand our planned stoppages and unplanned stoppages, we can see that they have individual subgroups we can go down into. Next up, we have generic utilization reasons. So utilization reasons describe an event that's happened that's changed the operating state of a piece of equipment. Each utilization reason is mapped to an equipment state that we've set up in the previous step. For example, a reason bottle jam could be mapped to the equipment state emergency stop, which is in turn mapped to the downtime equipment state type. The ones we're doing in this section here are generic ones, which can be applied to multiple pieces of equipment. If no utilization reasons exist, users will be able to assign an equipment state to a utilization event manually. So now we've imported that CSV, we can see that we've populated a list of, as I said, generic utilization reasons. These are reasons that can just be applied to multiple pieces of equipment. So lots of different pieces of equipment can have an emergency stop, can have no demand, can have jams, things like that. Now for the next tab, which is equipment utilization reasons. As I mentioned, the reasons we've set up so far are broad groups and broad reasons for all items, but sometimes we'll have individual pieces of equipment that need specific utilization reasons that are unique to them. This section allows you to restrict the utilization reasons that can be used with a piece of equipment. So if I drop in this CSV now, we can see that we've got some trees populated. So this CSV contains utilization reasons for specific pieces of equipment in specific areas of our hierarchy. So if I expand out Austin and I pick our Kappa 1, for example, we might have particular ones that we care about versus Case Packer 1. Same for the piece of equipment in Houston. So the reasons that we've set up so far are a pick list that we can provide to the operator at runtime. Now, normally what we want to do with MES systems like this, if we want to automate that, we want the value for how a machine is running to come directly from the machine or from a controller that's hooked up to it. We'll discuss mapping numerical values to these utilization reasons that we've created later on in the video. But for now, just know that we will be assigning those. So in this section here, we're going to be assigning equipment automation values. So the same way that I mentioned with equipment utilization reasons is that these are specific ones that might override some of the generic ones. These automation values are specific ones that will override the other automation values that we might be getting. So for example, a numerical code 1 might represent running for most of our equipment, but the numerical code of 1 might represent actually the stopped command for another piece of equipment. So we can set that specific nuance up here. That way when Insight receives the numerical code, it will map it to the correct utilization reason. So now we have that CSV imported, we can see just some examples of those. So the automation value of 111 correlates to the utilization reason Kappa running for Austin's Kappa 1. And that's our utilization reasons set up. So now we can go back to the wider equipment efficiency model. And now that we've got those set up, we can define our calculations for OEE. So in this CSV, we're providing the default production rate of a particular piece of equipment, the unit of measure that we're going to be looking at, the time span that we're looking at here, whether we're looking at units per minute, units per hour, that will vary depending on what type of process you're running. We're also looking at our targets for availability, performance, and quality. Now, these are identical for all my pieces of equipment, but in a real plant, those would obviously vary quite heavily. We're also defining a target OEE, so the multiplication of our availability, performance, and quality. And we're also defining a start and end utilization reason. These are optional, but they let us automatically provide a valid utilization reason when a production run is indicated as starting or ending. For us, we're setting it to running when a production run begins, and no demand when a production run ends because we will finish that order. Do note that if the column is empty, the current utilization reason that is present when a run starts or stops will continue. So in my case, if I got rid of this start utilization reason of running, we'd be running at no demand when we started a new production run because this would still be in effect. Now this might be overridden by an operator or by an automated data source. So you don't need to use these, but they are helpful just to make sure that we're starting in a good state. Next up, we've got our disposition reasons. So disposition reasons describe why a good or waste production count has been entered. For example, reasons for entering good production count might be the product's created and it's good, it's high quality. It might be a part of a process, so it'll be marked as in progress. Or you might be running graded production processes, so it might be grade A, grade B, grade C finished goods. Reasons for entering waste production might be things like an overfilled bottle, product damage, or out of spec, for example. So now I've uploaded my CSV. We can see that we've added some reasons for good or waste production, a description of what that reason is, so we can provide a little bit more detail than just the name. An automation value, so if we're receiving automatic values from the system, we'll be able to map numerical codes to these reasons. And then defining whether it is good or bad / waste production for the purposes of monitoring our quality metric.